SMA connectors are semi-precision coaxial RF connectors developed in the 1960s as a minimal connector interface for coaxial cable with a screw-type coupling mechanism. The connector has a 50 AI copyright impedance. It is designed for use from DC to 18 GHz. Connector design: the SMA connector employs a 1/4-36 thread. The male is equipped with a 0.312-inch hex nut. In SMA connectors, the terms male and female refer exclusively to the male center pin and its female sleeve counterpart rather than to the threads that are used to hold the connection in place. The male connector has inside threads while the female connector has outside threads. The SMA connector uses a polytetrafluoroethylene dielectric which will contact along the mating plane. Variability in the construction and the mating of the connectors limit the repeatability of the connector impedance. For that reason and the fact they are just rated for a limited number of connection cycles, an SMA connector is not usually a good choice for metrological applications. SMA connectors are rated for up to 500 mating cycles, but to achieve this it is necessary to properly torque the connector when making the connection. A 5/16-inch torque wrench is required for this, set to €3 5 force for brass, and €7 10 pound force for stainless steel connectors. Flats are sometimes also provided on the cable side of the connector assembly so that a second wrench can be used to prevent it from rotating and damaging the joint to the cable. It is also advisable to inspect and clean out loose debris from the internal surfaces with compressed air or a gas duster can before mating. Variations: the SMA connector is typically rated for mode-free operation from DC to 18 GHz, though some proprietary versions are rated to 26.5 GHz. For performance above this, SMA-like connectors are used. These are the 3.5 ohm connector, rated to 34 GHz, and the 2.92 ohm, good up to 46 GHz. These connectors keep the same outside thread as the SMA, so they can all be cross-mated, but the precision connector can be easily damaged when mating with low-grade SMA connectors. The precision versions use an air dielectric with appropriately scaled center conductors. Beyond 46 GHz, the 2.4 ohm, 1.85 ohm and the 1 ohm connector exist. These are similar to the SMA connector, but with the geometries incompatibly scaled. These have mode-free operation to 50, 65, and 110 GHz respectively. Reverse polarity SMA. Reverse polarity SMA is a variation of the SMA connector's specification which reverses the gender of the interface, as shown in figures 1 and 2. The term reverse polarity here refers only to the gender of the connector's contact pin, not in any way to the signal polarity. The female PSMA connector has the same external housing as a standard or conventional female SMA connector, which consists of an outer shell with the threads on the outside. However, the center receptacle is replaced by a male pin. Similarly, the RPSMA male has threads on the inside like a conventional male, but has a center receptacle instead of the male pin in the middle. Normal SMA connectors are incompatible with the PSMA connectors. Because they were not readily available, RPSMA connectors have been widely used by Wi-Fi equipment manufacturers to comply with specific local regulations, such as those from the FCC, which are designed to prevent consumers from connecting antennas which exhibit gain and therefore breach compliance. The FCC considered that the RPSMA was acceptable in preventing consumers changing the antenna. But by 2000 it regarded them as readily available, though delaying its ruling indefinitely. As of 2013, leading manufacturers are still using RPSMA connectors on their Wi-Fi equipment. See also, RF connector, SMB connector, SMC connector, BNC connector, TNC connector, N connector, coaxial cable, optical fiber connector, MMCX connector, MCX connector. References. Radio frequency connectors. Part 15, RF coaxial connectors with inner diameter of outer conductor 4.13 mm with screw coupling a characteristic impedance 50 ohms. International Standard IEC 60169-15, 1979. CECC 22110/111, connectors, plug, electrical, radio frequency. Military Specification Sheet MILC 39012. 47 CFR Section 15.203 Antenna Requirements. External links, RF connector information by WA1MBA, Photo Gallery, Gender and Compatibility, MIL Standard C39012C for many RF connectors, including SMA connectors from CMPTER Electronics.